310 was identifying agonists on groups, right? Who's working, because how they're working. Skeletal muscles aren't like cardiac muscles, where we got like a heart that does one particular job. Muscles will always have help. Skeletal muscles will always be part of a team. That doesn't mean we don't have superstars, but every muscle doesn't just work by itself to influence motion, okay? So 310 was trying to scrub our brains from just thinking of the bicep or the pec or the hamstrings or the calf, right? Layman's terms. And we have to think of muscles as groups. Once we identify an agonistic group, so you identify an agonist. And so let's say on this first test, I'm holding you accountable for the groups of muscles in the cervical group. External force is trying to push my left ear to my left shoulder. That's the external force. So the group of muscles I need are the ones that are pulling me to the right, my right lateral cervical benders. All that's saying is that it's the team of muscles that are trying to pull my right ear to my right shoulder. Okay? Once we identify the agonist, that's when we can take it to the next step and say, who are those muscles? Who are the individual players of the team? So my agonist in this example, external force is trying to create left lateral. I need muscles that are pulling to the right. I need my right lateral cervical benders, my right laterals. I figured out that I need my right lateral cervical benders. Who are those muscles? Whoever's on the right side of the Adam's apple, right? My right sternocleidomastoid, my right erector spinae. How do you learn who's on the team? I don't care. Just know who's on the team. You could use lists, you can memorize it, you could use my cross-sectional circle way to learn it. I'm never going to ask you to draw a circle. It's a tool, it's a teaching tool to help remember, well, who's on the right side of the vertebra? How do they sit in class? Who's on the right side? Right sternocleidomastoid, right erector spinae. The circles don't tell you if they're working. The circles don't tell you. They just tell you who crosses how so that you can see, once you identify the agonist, who's on that team. Do I need the right-sided muscles? Those are these. Do I need the left-sided muscles? These are these. Do I need the front-sided muscles? Those are these. Backside, and then the spinners, right? Now let's go on to contraction. My agonists are my positive muscles. Those are the ones activated. Those are the ones recruited above agonists. I mean, above resting tone. In this case, my right lateral cervical benders would be my right. Those are the ones that are on. My right lateral benders, true? Those are the ones that are positively working. So if the motion is in the same direction, if the motion is right lateral cervical bending, does that make sense? The motion is in the same direction as the muscles that are on, then I'm going to have concentric contraction. Remember, concentrics is like our way of saying positive work. That's 310. The added layer is who are in those groups. And if the motion is left lateral cervical bending, well, that's what a negative is. A negative is the movement is in the opposite direction of the positive working muscles, the muscles that are on above resting tone. Not rocket science. Rinse, wash, repeat. If we don't observe any motion and my agonist is working, right? Let's see, option number 3 is, then that would be isometrics. In other words, don't let me push your left ear to your left shoulder. In athletic training and in therapy settings, you're going to do manual muscle tests. You don't want motion. Don't let me push you here. Don't let me push you there. Don't let me push you here. There's no movement at all, but yet you're still turning on certain groups of muscles when you do manual muscle tests. There's no motion, but that muscle, those muscles are still working above rest. So in this case, I'm activating my right laterals. Those are right sternocleidomastoid, right erector. There's no motion, so it has to be working isometric. It's a type of work. Positive work, the movement is happening in the direction of my activated muscles pull. Negative work, the movement is in the opposite direction of my activated muscles pull. In isometric work, there's no motion, even though I have activated muscles pull. Let's do an application question from the past materials. Let's do now. Arrows sometimes can be tricky, but you know it's not tricky? Life data. In other words, our common sense. First of all, common sense. Let's get the picture up here. So what does that arrow mean? Well, it can mean a lot of things, but I know what's practically happening. The person has their hand on the front of the head. Gravity is trying to do something to the neck, and this person is probably not grabbing his head and yanking forward, right? So it's logical that this person is producing a force in that arrow's direction, an external moment. Okay? So here's a litany of questions, and you could either record them, write them down, answer them, then we'll answer them together. Identify the agonist at the cervical vertebra in this manual muscle test, in this exercise. And you answer that by asking you, well, why do they need to work? Why do you call firemen to do a job? Because there's a fire. Why would you call an electrician to come to your house? Because there's a problem with electrical. Why do you call a plumber? In other words, we have to identify who we need by why we need them. In this case, it's about external forces. The external forces are trying to do something to the neck. So my positive agonists are going to be those muscles that pull in the opposite direction majority of the time. Are there exceptions? Sure. We went over those in 310, but those are really rare. Gravity's trying to adduct me, and I want it to go faster than what gravity can offer. 99% of human movement is your muscles pulling in opposite directions of external forces. So that's the ones we're going to start with. So you need to be able to identify the agonist. In 310, we could end it at cervical flexors, extensors, da-da-da-da-da. 415 is like, well, now I need to be able to identify who are those muscles? Who are those major muscles that are pulling in those directions? Do that now. Identify the agonistic muscles who would be working. So you identify your agonist, and then you either use your lists, your memory, or your circles to say, well, who do I need? Where do they sit in class? Or if you haven't learned that one circle yet for this test, that's okay. Go to your PDFs and look at it on the sheets. All I'm asking you to identify right now is who are the muscles that I would need to do a job to resist gravity and this person pushing my head back? Do I need flexors or do I need extensors? Flexors. Now, what does flexors mean? That doesn't mean flexion. Just like in 310, position doesn't mean motion. Flexors, it's plural. It's flexion pulling muscles. It's muscles that pull in a direction of flexion. But that doesn't mean they're always going to cause flexion. Just like when I lift up on this book, that doesn't mean the book's always going to go up. I could keep it here, or I could let it go down while still pushing up. Flexors are just flexion pulling muscles that specifically cross the neck in the front. They cross anteriorly. It doesn't matter what they're anchored to or yanking on. It's how they cross is what determines function. Pull. Who are the muscles that cross in the front? For this class, my right and my left sternocleidomastoids. Those are two separately innervated muscles. I have one on the right side and I have one on the left side. Make sense? So your circle didn't tell you who you need. Your knowledge of how muscles work helped highlight. So in other words, imagine you're looking at the circle and you're saying, okay, who do I need? Well, he's trying to extend me, so I need flexors. That front area of your circle should light up in your head, like turning on, positive. Positively, I need the muscles in the front. Make sense? Once I know that I need those muscles, I think this will work better. Remember, I am a caveman. When it comes to tech, that was for 3 seconds. That chair insulted me. I have to get it back. It insulted me by getting in the way of my steps and I tripped with it. I hope you learned your lesson, chair. If you can't see, let me know, but I'm not changing the picture. Agonist. Muscles doing a job above rest, turning those on. My positive pulling muscles, right? My cervical flexors. Who are those muscles? My right sternocleidomastoid and my left sternocleidomastoid. Cool so far? Canceling out frontally, canceling out transversely, pulling anteriorly, pulling forward. Contraction now comes from this. If there's no movement, those muscles are still doing a job. Think of it like this. If he relaxed all of his cervical flex, his neck would snap back. Work isn't literal movement when it comes to human movement. It's physiological work. There's still, even though there's no mechanical movement, there's still enzymes processing and ATP happening, right? There's still movement. The factory is still rolling, even though we may not see product coming out. You can't hold that position all day. The muscle's going to get tired. This is about physiological work. So I identified my agonist. If I observe no motion, that has to be isometric type of work. If I observe flexion, so let's say this person in this situation is saying, okay, don't let me push your head down. Don't let me push your head down. Okay, now put your chin to your chest. And he lets off a little bit and lets the person start to flex. The agonist is still the flexors. But if I actually observe flexion, positive pulling muscles, the motion is in the same direction as the muscles pull, that has to be concentric contraction. If you observe extension, sorry, with my dyslexia, I forget if it's S or T. If you observe motion in the opposite direction of the agonistic muscles pull, that's what a negative is. That's eccentrics. Guys, this is so important for me to teach you that we literally are going to spend the whole rest of class learning specific muscles and applying concentrics and eccentrics, because that's how, I don't want to say tough, but and it's not even students, people have a tough time understanding concentrics and eccentrics because it's a variable that is defined to you, but it's not practiced. And we can't get better at any activity unless we practice it. Any questions so far? Okay. How about holding this position, do I need flexion pullers or extension pullers? We should be able to do this pretty quick. Extension pullers. Why? Because gravity is trying to flex you. And if you use muscles that are in the same direction as gravity, you literally yank your head down. Make sense? Make sense? In other words, he needs the muscles in the back of his head. He needs the muscles that are pulling this way because your gravity is trying to. Here's a thought experiment. If he relaxed, if I had a remote control that could turn off his muscles, because think about it, muscles are nerves and that's electricity. It's internal electric wiring. If I had a fancy magical remote control that I could turn off the muscles at his neck only, I turned them off. What would happen to his head? It would fall down. What motion would that be at his neck? That's what I'm trying to say. Gravity's trying to flex him, so he doesn't need muscles that pull in the same direction. Yank his head down. He needs cervical extension pulling muscles. And we have an easy word for that, cervical extensors. Now in graduate school, man, you're gonna learn, you got a bunch of them, because in order to erect your spine all day and not get into fatigue, you gotta kind of chop up that work between a lot of different muscles. For this class, we're grouping the groups. But you know what's cool? They don't crisscross over the spine. You have your spinous processes in the middle, you have some on the right side, and you have some on the left side. The right erector spinae, the left erector spinae. Think about it. You can't walk all day with your arms out, but you could walk all day with your neck up. You've got to chop that work up between a lot of different fatigue-resistant muscles. So at the end of the day, you're like, man, my neck is killing me. I got a head of those muscles are tired. I've been working all day, keeping you from falling asleep at 8:30 a.m. class. Who are those muscles? For the purposes of this class, well, who crosses the neck and the back? I need posterior crossing muscles to do this job. My extensors, they would be working. I visualize the posterior part of my circle lighting up, highlighted with a positive. If I see no movement, the positive pulling muscles are doing no movement through isometric type of work. If I observe extension, let's say the person's doing the plank and someone walks in the door and they want to look up. Well, gravity's still trying to flex me, so my extensors would still be working. Extensors pull in the direction of extension. So if I see extension, extensors do extension through concentrics. In 310, we did A plus B is equal to C. Remember that? Agonist, movement, and if the agonist lines up with the motion, it's concentric. All I'm doing is taking a biomechanical positive and negative, and this is why we call them negatives, and this is why. It's the same stuff. If you observe flexion, let's say his watch or his phone is down there and he's holding this position and he wants to look down. You know what probably he wouldn't do is, he probably would not use his flexors to do that. It would still be the extensors to allow the flexion through eccentric contraction. Extension pullers are going to allow the flexion through eccentrics. The positive working muscles will still be responsible for movement in the opposite direction of their pull, and that's what a negative is. Make sense? Think of it probably the most classic way during a bench press. The reason this part is called a negative is because the muscles are trying to make the bar go up. So if the bar goes down, it's in the opposite direction of the working muscles. Well, they call it a negative. Same thing here. If you have flexion, those extensors are pulling here, and you have motion in the opposite direction. That's why it would be called a negative. Let's do some stretch stuff. things about muscles is their consistency. Muscles only pull. And with that consistency comes the concept that if I move any joint, if I have joint motion, regardless of contract, it doesn't matter. Flexion pulling muscles at my wrist are going to get shorter as I flex, and extension pulling muscles are going to get longer as I flex. As I extend, extensors are going to get shorter, flexors are going to get longer. Remember, contraction, there has to be multiple criteria. Just because a muscle shortening or lengthening doesn't mean it's contracting. That's like if someone's laying down on the table and they're relaxed, I can passively flex and extend their elbow, and the flexors are going to get shorter and the extensors are going to get longer. But if they're not doing a job, who cares? They're not working. You're not going to get tired if someone passively ranges the motion, right? Does that make sense? So again, for contraction, that's why I use the word work. It's being lengthened, shortening, or staying the same length while doing a job, while being turned on above resting tone. This is a positive side, not an anti-vampire side. This is a safe place for vampires, all right? Halloween coming up. Does that make sense? Now, when it comes to stretching or muscles being lengthened, position is really important in our world. So what we have to understand is that if I can see how muscles cross the joints, any flexion puller at my hip is going to get longer if I extend the hip. Any extension puller at the hip is going to get longer when I flex the hip. Kind of common sense. So if I bend my neck to the right, I'm stretching muscles that pull to the left. And if I bend my neck to the left, I'm stretching muscles. Guys, do it. You feel it. Put your left ear to your left shoulder and feel the stretch on the right side. Okay? So let's look at the position on the left. How is the cervical vertebra bent? Is it bent to the left or bent to the right? Remember, it's about their perspective, not yours. You can become that person, but I know in human anatomy, y'all were taught this is a right humerus, regardless of if you're looking at it and it's on your left. So if this is a right humerus, this is a right shoulder, this is a right elbow, this is a right ear. Is she bent to her left or to her right? Left. Bent to the left, that means I'm going to be stretching muscles that pull to the right. Who are the muscles that pull to the right? The right lateral cervical bending pullers, or as we like to call them, the right lateral cervical benders. Who are those muscles? I don't care how you learn it. Memorize it. Or you look at your circle and you say, I'm bent to the left, my right side lights up. I'm stretching the muscles that are on the right side of the Adam's apple, right sternocleidomastoid, right erector spine. If you notice a pattern, I do not teach you to go right to muscles because that's where we make mistakes. I'm teaching you a process to make sure that we're stretching the right muscles, we're working the right muscles. Guys, in your fields, there's going to be sometimes where certain stretches for certain injuries or certain palsies are contraindicated. Like there's going to be certain times, don't do this because it's going to get in the way of our rehab. You better know what's working, what's working what. You better know what's stretching what. We can't play this fast and loose game with core anymore. When you guys get to a certain level, we have to know what we're working and how we're working. Sometimes there may be exercises or part of the rehab where you only want to do concentrics. And sometimes you only want to do eccentrics. You need to be able to know how to set those things up. And that's why we practice this stuff, okay? Picture on the right. How is she bent? To her right. Now dip, baby, dip. Yeah, to the right. No, that was too long. All right, stop, bro. That's why my kids call me a boomer. She's bent to the right. So what group of muscles is she stretching? The rights or the lefts? The lefts. Who are the lefts? That's what I'm trying to teach you. It's everything that crosses the neck on the left side. Left sterno, left erector. Those are the easy ones. The harder ones, and I try to explain the whys in the videos, this is the harder ones because it goes against our instincts. Thank you, sir. I promise no more dad jokes for today. So we're not. I'll probably get him instant prepared for that big football game tomorrow. This is harder, but you know what's not? The concepts is the same. The concepts are the same. Who am I stretching? Who's being lengthened is dictated based on my position. What's the position on the left side? Is she twisted to her right or to her left? Is she right transversely rotated or left transversely rotated? The photo on the left. Great, great. She's twisted to the left. So that tells me she has to be stretching muscles that pull to the right transversely. Does that make any kind of sense? She's stretching right transverse cervical rotation pullers. Guys, this is why I teach it the way I teach it. Because if all we did was just say muscles, we would lose sight of why they're being stretched. If all we did was call these muscles Tom, Jerry, and Bobby, if we didn't add in their direction of pull, it would be harder for me to teach you why certain muscles are being stretched here when your instinct is like, I don't see it. There's no way. That doesn't make sense. She's stretching right transverse cervical rotation pullers. Do we all agree? Who are those muscles? The left sternocleidomastoid and the right erector spinae. And that is weird to certain people because you're like, how in the world am I stretching a muscle on the left side if I'm looking to the left? Someone be honest. Isn't that kind of weird? This is out. Only the most expensive props for this class. Anatomical position, left sternocleidomastoid, sternum clavicle mastoid process. This left is trying to pull transversely, is trying to pull my left ear forward. In the videos, I say, if you got in trouble and your mom grabs you by one ear and yanks it forward, if she took your left ear and pulled it forward, wouldn't she be trying to make you look to the right? And if she took your right ear and pulled it forward, wouldn't she be trying to make you look to the left? You remember that analogy? So watch this. Left sternocleidomastoid pulls in a direction of right transverse cervical rotation because it's trying to pull my left ear forward and thus make me look to the right. So look what happens when I actually move in the direction of the pull. Slack. It gets shorter. So look what happens when I move in the opposite direction of the pull. It gets tighter. It gets longer. This is a three-dimensional concept here. Some students might say, well, why do I feel it if I'm looking to the left, right? I'm looking here, and I don't understand why I would feel a stretch on my right side if I'm shortening my right side. And here's the answer. It's because your erector spinae now starts to come forward, and the stretch you feel is your right erector spinae, not your right sternocleidomastoid. But I feel the stretch right here on the right side. Yeah, from your erector group that's going more and more and more anterior as you rotate your neck. Does that make sense? So it's the same concept. What's the position? I'm twisted to the left. What muscles are being lengthened? The ones that are pulling to the right. Who are the right pullers? That's where your circles come in. That's where your lists come in. But do you see what I'm trying to preach to you is that if we didn't take these steps, you would lose track of seeing why this muscle is being stretched. As I look to the left, the muscles that pull me to the right are being lengthened. So who would I be stretching on the left? To the left, I'm stretching right transverse. Who are right transverse? Left sternocleidos, right erector spinae. Sense? Now, eventually you'll get to some combo stuff, which is cool. Like, in other words, my right sternocleido is a left lateral flexor and left transverse. So you can do combinational stuff. You can be like, all right, bend to the right, that gets it. Now extend, that gets it even more. And then you can also, well, it's trying to maybe do, so you can start to do combinational things as you need it, but it all comes back to how the muscles pull. None of that application has anything to do with origins and insertions. It's a function of pull. The way I know how to stretch flexors is because they pull that way. So I need to extend to stretch what pulls into flexion. Flexion. All right. What about one on the right? Position, right transverse rotated. So the right transverse rotators on slack, they're shorter, but the left are longer. The lefts are being stretched. Now remember from 310, right and left means two different things in two different planes. Right and left lateral, right and left transverse. That's why we add those other words in there. So this is a transverse right and left, not a lateral right and left. Okay? She's here. That means she must be stretching right sternocleido and left erector. Picture on the right, her position is right transverse cervically rotated. So that means she's stretching left transverse cervical rotation pullers. Who are those muscles? You visualize your circle and you say, who's trying to pull this way? Bang, bang. Right sternos, left erectors. Or if you just memorize the list, I don't care. I just want you to know who's getting stretched, who's being worked. Does anybody need me to repeat, or maybe it wasn't enough, of how the cross-sectional circles work? Did y'all watch those videos? Y'all need me to re-go over this? This is your neck. Being serious. I'm expanding it out. That intersection is your spine. And I know the spine isn't in the middle of your neck. This is a reference. Muscles function not based off of where they start and where they finish, but how they cross joints. My sartorius starts in the front of my leg and it inserts in the front of my leg, but it's a knee flexor because it crosses my knee in the back on its way to insert in the front. How muscles cross determines their function. I can't draw the circle like this because you couldn't see it. I had to rotate it on the board so that we can see it. However, on your desktop, that's literally how the circle would be. It'd be like this. It's the front, it's the back, left side, right side. But if your desktop is like this, then we have to rotate so that you can see. The muscles that cross the neck, the cervical spine, anteriorly, so this is the anterior part, this is the posterior. side, this is the left side. Anterior, posterior, right side, left side. Right transverse, left transverse. You know how I know that? Just look again. Right transverse, left transverse. So I'm going to have muscles that pull in the direction of flexion. We call them flexion pulls. Those muscles have to cross the neck anteriorly. They have to cross in the front in order to create a moment or a torque of flexion pull. My cervical flexors are going to cross anteriorly. They're going to sit in the front of class to pull this way. My extensors are going to sit in the back of class. They're trying to pull the back of my head to my spine. Flexors, extensors. So far, so bad. Right lateral benders. Those are the muscles on the right side of the anterior-posterior axis. We have a bilateral axis. That's what this axis is. Muscles that cross in the front of the bilateral are going to be flexors. Muscles that cross posterior are going to be extensors. There's my anterior-posterior axis. The muscles that cross on the right side are going to be right lateral pullers, and the muscles that cross on the left side are going to be left lateral pullers. And then in the videos, I talk about PE. This is the bilateral and the AP are like traditional class. Recess is the transverse plane, because that's the merry-go-round. We get to go outside and play. Here's the polar axis. Recess time. Polar axis. I'm going to have right transverse pullers, and I'm going to have left transverse pullers. Muscles that are trying to pull me to the right transversely, and muscles that are trying to pull me to the left transversely. Now, how do I coordinate or communicate all of that information in one simple circle? Like this. Right sternocleidomastoid is a cervical flexor because it crosses the neck in the front. It's a right lateral cervical bender because it crosses the neck on the right side. And it's a left transverse cervical rotation puller because that's how it's trying to spin the merry-go-round. All of that in one little picture. And if you're like, how in the world could something on the right try to twist you to the left? That's what I just explained. You take your right ear and you pull it forward and make you look to the left. This muscle runs from here to here in 3 dimensions. And it's trying to bring your right ear and line it up with your sternum. So what are the 3 functions of the right sternocleidomastoid? I don't have to memorize a list. I just got to say, where's it sit? It's anterior, it's a flexor. It's on the right side, it's a right lateral. Let me see how it plays on recess. It's a left transverse. That's how it pulls. So if I want to stretch the right sternocleidomastoid, let's say someone has, let's say someone has a nerve problem to their right sternum. Let's say their right sternum's tight. You got to stretch it. Don't you have to know how it pulls in order to put the position to stretch it? Especially combinations. Well, it's a flexor and a right lateral, so I want to extend and bend to the left. I really want to get it in 2 different dimensions. You have to know how these things pull. Watch this. Left sternocleidomastoid. It sits in the front as well, so it can have the same function as the right side in the satchel, right? It's going to be a flexion puller. But it doesn't sit on the same side of class. The right sternal is on the right side of the AP, and the left is on the left side. So the left is going to be a left lateral puller. Make sense? And they also fight for the merry-go-round. They don't play on the same side of the merry-go-round. The left is trying to spin you to the right. You take your left ear and you yank it forward, you're trying to make you look to the right. Transversely. Left lateral, but right transverse. So what are the three main functions of the left sternocleidomastoid? Cervical flexor, left lateral cervical bender, right transverse cervical rotator. And all I have to do is just see it. I just have to see how it sits in the neck. It sits in the front on the left side and it's trying to play PE like that, like that. It's trying to spin the merry-go-round like that. Who watched the videos that I posted? Did I explain this in there or not well?
Explain the exact same.
Right. Thank you. Because my confidence is shaking right now.
I want you getting the videos to be helpful with the like you place them like this. So they're in the front.
Yeah.
Okay, they're working together.
Yeah.
They're been together.
Yeah. Well, they're
nice. By themselves. Yeah. I use these two fingers.
Good for you.
This way.
Absolutely. If we were in outer, to your point, I love that point. If you were in outer space or we turned off gravity and I took out all the muscles in the body and I just said, hey, right sternocleidomastoid, do what you do, this is what would happen. Forward and twist. Good. All right, guys, this is a small class.
Whenever you talk about the neck stretches, like, or no, whenever you say you turn right, okay, which direction is fine is being stretched?
It's okay. Can we put a pin in that question? And I'm hoping that it'll make sense once I get the erectors in the circle. Okay? So here's the last. All right. Posterior crossing muscle, cervical extensors. The right is on the right side of the AP, right lateral. Left is on the left side of the AP, left lateral. Now let's look at PE. Force couple. Force couple. That's their rotation. So in other words, the left erector is trying to spin the merry-go-round the exact same way as the right sternum. And the left sternum is trying to spin the merry-go-round in the exact same direction as the right erector. They're opposite sagittally, they're opposite frontally, but they're not opposite transversely, which is super convenient when you're trying to look and have the cancellation here and the cancellation here and the force couple there. Now let's look at your question. If I know that my cervical flexors or my right sternocleidomastoid and my left sternocleidomastoid. I'm setting it up. I'm setting up your confidence, all of you, to see the horror question. We know that our cervical flexors are my left and right erector spinae for this class. And I also know that I'm going to stretch those muscles when I extend my neck. These muscles only pull. So if I have cervical extension, the flexion pullers are going to get longer. Who are my right transverse cervical rotators? Who's trying to spin the merry-go-round to the right? Who's trying? Who pulls that way? Who's trying to pull the merry-go-round to the right? Do you see that it's the left sternocleidomastoid and the right erector spinae? Left sternocleidomastoid, right erector spinae. So with that same logic, how am I going to stretch the left sternocleidomastoid and the right erector spinae? I don't want to rotate to the right. I want to rotate to the left. I want to position my neck left transversely so that I can stretch the right transverse cervical rotators, the right transverse cervical rotation pullers. And this is how it works. My left is trying to twist me to the right. So how would I stretch it? By looking to my left. I got it longer. I know it seems weird, but think about it. If with your finger, I love the finger analogy. If you look in the direction of its pull, these fingers get closer. If you look in the other direction, look at my fingers get further away. I'm stretching the left sternocleido as I look to the left. And that's why you have me in this class, because that's not easy to see. Not just for you, for all of us. I struggled with this too. I was like, that makes no sense. My job is to try to make it make sense. Guys, not every muscle is going to be like the hamstrings. I wish they were. There's going to be some freaky stretching muscles. And it mostly comes into that third dimension of pull. So again, left sternocleidomastoid is trying to twist me to the right. So if I actually look to the right, I'm not stretching it, I'm shortening it. I actually want to look to the left, stretch the left sternocleido. And I'm trying to get you to see it and not just memorize it. And it's tough, guys, it is. It's tough. But you know why we do the hard things? Not because they're easy, but because they're difficult. And it'll make you better clinicians. Imagine, just tossing it out. You're going to learn this. You're going to practice it. It's going to get easier. But imagine in a clinic, someone's like, yeah, this person's left sternocleidomastoid needs to be stretched. Imagine not putting that person in the right position to stretch that muscle. For 2 weeks, they're like, well, why aren't they getting better? Well, we've been doing stretches. Oh, you've been doing the wrong stretch. My bad. It seemed like it was right. Come on. Good answer. Guys, this one circle gives you so much information. That's why I push you. I don't make you have to do it. Who are the cervical flexors? The anterior crossing muscles, cervical extensors, the posterior crossing muscles, the right laterals, the ones on the right side of the AP, the left laterals, right transverse, left transverse. This circle doesn't tell you who's working. 310 helps you to highlight who do I need, right? Like for the person who was doing the plank, I highlight these because I know I need these. Who are they? What if he was doing a side plank on his left side? Wouldn't I need the muscles on the right? Highlight, positive. He's doing a plank on this side. I need the left. Highlight, positive. And if I see no motion, they're working isometric. If I see motion in the direction of the highlighted agonist, concentric. And if I say motion in the opposite direction of the highlighted agonist, that's what a negative is. That's what eccentrics are. How do I stretch my right erector spinae? Well, I want to flex. I want a left lateral bend. And then here's the tricky one. Okay, my left erector spinae, how is it trying to spin the merry-go-round? It's trying to spin the merry-go-round to the right. So I don't want to look to the right. That's like saying, how do you want to stretch a hamstring? You don't want to extend, you want to flex. To stretch an extensor. If the muscle is pulling right transversely, I want to look to the left transversely to stretch something that's trying to spin the merry-go-round to the right. Better? And there's a reason we start off with the cervical. I'm only holding you accountable to 4. And each one has its little spot. And each one is trying to play recess. It gets more complicated. There's more muscles here. There's more muscles here. Some classes are small. Some classes are big. In my little town of Delcom, we didn't graduate with a lot of people. Some classes, like a KNES, a big class. But I thought it would be important to start off with the easy one to understand how this stuff works. Better? Rewatch the lectures if you need, okay? And Monday we'll do a guided review. I'm going to let